Hello and welcome to rotations through points not at the origin. Please make sure you have your worksheet in front of you. So in this case, we are going to try and rotate point A through the point P, which is 5, 2 in this case. So I'm going to zoom in so that we can kind of look at it. So in this case, we are trying to rotate the coordinates of A through point P, and it's unclear because there is no rule to rotate through the coordinate 5, 2. So what I've come up with is a set of rules that we're actually going to follow, and then we are going to graph it after. So in the first case, it says, determine the translation that moves the center of rotation to the origin. So when I talk about the center of the rotation, I'm talking about this point here, P, which is 5, 2. In order to move that to the origin, think about it for a second, we are going to take this point and we're going to move it left 5 and down 2. So the correct translation would be negative 5, negative 2. So I'm going to write that right in here. Negative 5, negative 2. So we're going to move left 5 and we're going to move down 2. Now it's super important that we move the point that's to be rotated the same translation. So I'm going to put negative 5, negative 2 right here. And think about that for a second. That's going to move 9, 7 over to 4, 5. So we have just moved the point of rotation to the origin. Now we're going to apply the rotation of either 90, 180, or 270. And in this case, it is 90 degrees. So some of you might remember that the rule for a rotation of 90 degrees is in fact negative y, x. So I'm going to take this coordinate, which is 4, 5, and I'm going to rotate it 90 degrees. When I do that 90 degrees, following the rule, it winds up to be negative 5, 4. Now, unfortunately, that is not the final answer. We have to now take that same coordinate, negative 5, 4, and do the opposite translation from step 1 to move the coordinate back. So we go back up to our step 1, and that translation was in fact minus 5, minus 2. So if we had moved things to the left 5 and down 2, now we're going to move them to the right 5 and up 2. So what I'm going to do in the opposite direction, I'm going to put a positive 5 and a positive 2 right there, and the coordinates of my final answer are going to be 0, 6. Now that might be a little confusing, but we're going to take a look at it graphically. So what I'd like you to do is plot the point 0, 6. I'm going to zoom in so we can see where 0, 6 is. So everyone, 0, 6 is going to be right about here. And we're going to call this A prime. Now think about it for a second. If I was to connect P with A, and then I was to connect P with A prime, you will notice something kind of interesting. We have created a right angle, or a 90-degree angle right here. And I know that that's a 90-degree angle because of their slopes, but also because we just did the rotation of 90 degrees. And when I look at my picture, that does appear to be the center of rotation. So now we're going to take a look at the next page. So flip over your worksheet, please. And it looks like this. Now in this case, we are going to move this entire triangle, or rotate this entire triangle through point P. Now this is a little more difficult than rotating through the origin, but we're actually going to follow the same steps. So we're going to focus on the directions on the bottom. And think about it for a second. It specifically says that we have to determine the translation that moves the center of rotation to the origin. So the center of rotation is at 4, 1. I'm going to move left 4 and down 1. So think about that for a second. The translation that I'm talking about is left 4 and down 1. So I want you to write capital T, negative 4, negative 1. And then we're going to move all of the coordinates to the left 4 and down 1. So now let's take a look. In this first example, 1 comma 6. Now remember, I'm going to take the 1 and I'm going to subtract 4. I'm going to wind up at negative 3. I'm going to take the 6 and subtract 1 and wind up at 5. I'm going to do the same thing for all the coordinates. 6 minus 4 is in fact 2, and 6 minus 1 is in fact 5. 6 minus 4 is 2 still, and 3 minus 1 is 2. So I have those coordinates. Now, I've potentially moved the triangle so that it is in line to be rotated around the origin. So the next step of that is to apply the rotation, in this case of 270 degrees. So you're going to write rotation through the origin of 270 degrees. Now, some of you might remember that technically the rule for that is x comma y becomes y comma negative x. So these coordinates are going to be 5, 3, 5, negative 2, and 2, negative 2. Again, applying that same rule for a rotation of 270. The last step is to move the triangle back to the original position by undoing the translation from step 1. So step 1 over here, we subtracted 4 and subtracted 1. So now what I'm going to do is I'm going to add 4 and add 1. And my new coordinates are going to be 9 comma 4, 9 comma negative 1, and 6 comma negative 1. So basically, I took all the steps. I determined the translation that moved the center of rotation to the origin. Then I translated the coordinates, applied the rotation, and then moved them back. So now I'm going to go back to the top of the picture, and I'm actually going to plot this triangle. I'll do it in red. So the first coordinate is 9, 4. Let's see. That would be this coordinate right here. This is going to be my A prime. The coordinate for B was 9, negative 1. This one right here, so it's going to be B prime. And 6, negative 1, so that's going to be right here for my C prime. And then I'm going to connect them with a straight edge. And this is what my picture looks like. So I have taken this triangle, rotated around point P 270 degrees in the counterclockwise direction. Okay, we'll pick this up next class. Thanks, and I'll see you later.